So this electronegativity and polarity actually is part of your chapter 1 syllabus. I'll go very fast as it's not very complex to see. Try to conclude this one maybe within 20 minutes. Right? There are two graphic or two tables to refer for this section. So this section, you should, at the end of this section, you should be able to understand or explain why water and oil do not mix, or why water sometimes do not mix with other compound, or when we want to remove some stain or want to remove some marking on your cars, you use some certain solution to remove it, like sticker solution and also all these things. This chapter will answer all the questions. Okay. All right. So the keyword they're looking for is either we need to identify if the molecule is polar or non-polar. This one will come out in your final exam. So this will be in your final exam question, right? For your test one, maybe no. Final exam, sure this one come out, right? Yeah. So you will see this kind of illustration. Oil will float with water on top of water. Even you stir it, it still cannot mix. Right? So we need to answer why. Why water and oil do not mix? So we start by looking at the Levi's model of the water. So Levi's water, they have two bonds, and previous section before the break, you know there's a shape of geometry for that particular compound, right? So for water, you have O and H, and we have a lone pair. So this one will give you some angle, right, in the geometry. What else? So as you can see in the 3D dimension, the geometry, actually the electron is running here and there and do not share equally. So here from the illustration, oxygen take more than the hydrogen. Right? Okay, we start with electronegativity. Electronegativity, it means tendency to become negative. This one you learn in your chemistry 1, right? So electronegativity means the tendency to become negative, right? So or in my slide, I write in the another way is ability of an element to attract electron, means when you attract electron, it become negative already. Okay, you become negative charge, or tendency to become negative charge. The higher the number, the more power it can pull electron. It means it's hunger for electron, right? Okay, OH, this is a dipole moment. If you have O and H, you see something like this. So in here, this side, you know, O and H, if you refer to periodic table again, hydrogen is at the top. The top, as you have on the top, is more easier, and the top end is on the left. So it's easier to let go electron if you are group 1, 2, 3. Right? On the left of the periodic table, it's more easier to give electron. So hydrogen even is very easy to give electron. So it means its tendency to become positive charge. How you tell chemists that that element is tendency to become positive charge? You write delta positive. Right? So oxygen is on the group number 6. So it's more easier to attract, receive electron. So you write delta negative, means it's more easier to become negative. So by this understanding from the periodic table and the illustration by this diagram, right? And why this diagram O is bigger? By referring to periodic table again. Oxygen is you look at the row. Row means orbit. Oxygen, see, oxygen is below hydrogen, right? It's at N2, right? Row number 2. So we have 2 orbit. Hydrogen only have 1 orbit. So the shape, if you draw shape of the orbit, oxygen will be bigger than hydrogen. And if you look at electron, we talk about cloud. So the pink color actually is a possible position of the electron. Electron can run anywhere they want, but it's within the orbit, right? So for this session, actually just want you to show presentation of positive terminal and negative terminal. H will become positive terminal. O will become negative terminal. Means how you write in the chemical way. If that element more tendency to become negative, you write delta negative. If that element is more tendency to become positive, or in other way is you flip this word, electronegativity, it will become electropositivity for hydrogen in this case. So you write delta negative means oxygen is electronegativity higher than the hydrogen, something like that. So here you have a dipole moment. Dipole means you have a north pole and south pole, for example. You have positive pole and negative pole. So this is dipole. Dipole means you have 2 different charges, 2 different attraction, electron attraction, right? Okay. So yeah, so this one I already explained. So if it's electronegativity means it's more tendency to attract electron. So you can find a loss of electron around oxygen in this case. Okay. So yeah. So this slide explain why we put as delta negative, delta minus is because it's partially charged, negative charge. In mathematics, you see this delta, or else in physics, you will see delta, but you might not use delta in physics often. When you go into degree program later, you'll start to see partial differential and so on. Then you'll see this symbol. Okay. This one you read. How dipole moment can be formed is uneven electron sharing, because you have a positive pole and negative pole, then you have this dipole moment. Yeah. Why this one is okay? So once you have positive, negative, n, one is positive n, negative n. Once you have that one, then there is a polar. Is a something belongs to polar something. You use the word polar when you have positive, negative, unbalanced charges. You use the word polar something. In this one, why covalent bond? Definition, still back to definition of ionic bond and covalent bond. Ionic bond is metal plus non-metal. Covalent is non-metal plus non-metal. So if you check periodic table, hydrogen is a bit special. Hydrogen is considered in the table that I give you is metal. I think it's non-metal, right? Metal. Hydrogen is a special element. In the periodic table is metal, but it can be non-metal, right? But most of the time, hydrogen will give electron, right? So this one is polar covalent bond. one you read, this one you read, this one you read. Okay, important is this table. This table is tell you the electronegativity of that particular element. The higher the number means it more tendency to become negative. Means it can pull negative charge to them. For example, the highest in this chart is F, 4.0. The lowest in this chart is CS, 0.7. If the question asks you to compare side by side, CS and BA, which one is more electronegativity? Which one is more tendency to become negative? BA. So if these two put together, CS will become positive pole, BA will become negative pole. It can either become positive or negative. Right? So the higher number will always become negative side or negative pole, and so on. Okay. And you can see the helium, argon, and all these, they are stable element. When it's stable, you don't have electronegativity. Okay. 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 So this one, if two elements identical electronegativity form a covalent bond, they share electron equally, so there are no dipole moment. So if they are same, for example, if you see this one, same number, for example, Si and Ge, they form together. They join together, they become no dipole moment, means this is become a non-polar compound. If they are same number. This one very near, this one very near. You can sometimes you can say them also non-polar if you want. If they're very, very near. Okay, but left side and right side will have a very drastic one. If you put left side combined with the right side, it will sure become polar compound. Okay, so if you refer this one, electronegativity and the periodic table, you can see actually, for example, if you go down the periodic table, electronegativity will reduce. If you move from the left side of the periodic table to the right side, electronegativity will increase. Group 1, group 2, until group 5, 6, 7. As you move to the right, will become more and more stronger. You have more tendency to pull electron if you move from group 1 to from left side to the right side of the periodic table. So you can see there's a uphill here. It's an uphill here, right? So this is how you read periodic table. So if you understand periodic table, you can visualize what actually happened in the chemistry, right? Okay, the rest you read. So for example, chlorine, non-polar, right? Same element, non-polar. Okay, NaCl, salt, then you become ionic compound. Na plus Cl become ionic. Metal plus non-metal, right? So there will be a large electronegativity difference because they take something from the left, combine with something on the right on the periodic table. Then you will form large electronegativity. Okay, so this one is non-metal. Non-metal means they will form covalent. Polar covalent. Right? Polar covalent. For example, HCl, right? So HCl, you write delta positive because it's on the periodic table, it's on the far left top. Cl is somewhere on the far right. So you take something from the left, my right, right, you will form a polar component, right? Okay, so these are the table that you should memorize. It won't be given. This table won't be given because only 3 rows to remember, right? So if the electronegativity difference means you take the number on this table, let's say you take CS and BA, the difference between two is between 0 to 0.4, near to 0 different. They will form pure covalent. This one you need to memorize. Huh? This table won't be given in test or final exam. You need to memorize, and this one will be given based on this table, electronegativity table or periodic table. You know to which type of bond is being formed. Only 3 types: pure covalent, polar covalent, or ionic. 3 types only. Based on the difference of number. If it's very large, more than 2, for example, CS plus I, for example, you put something left to right, more than 2, it becomes ionic bonding. If it's between 0.4 and 2, then polar covalent. Most of the question will ask you polar covalent question. Okay, for example. Okay, so this is an illustration of the 3 types of the bonding in graphical things. So because some of you are unable to imagine what is this and so on. So if it's a pure non-polar covalent bond, pure covalent also known as non-polar. Okay, just for info. Pure covalent bond also known as non-polar. Polar covalent bond, then you in your diagram you need to put in delta, negative, positive, and so on. Okay, ionic bond straight away have positive, negative charge. Delta means very, very small difference. If you have big different charges, then become ionic. If very small, but they still join together like magnet, a weak magnet, then they form a polar covalent bond. Okay. Okay, so this is just a check whether you understand or not based on the numbers of electronegativity. So you can flip to I give you the table, right? The table I give you on tutorial question 81 and also 77. You based on these 2 diagrams, answer this question. SRF, you refer to the table, the difference, delta E, how many? Delta En. You need to calculate if this kind of question come out, you need to write delta En equal, and then from the table you write lah. You write for the higher one, you always get positive number. So you always get the high number minus low number. So SR number, Camero, SR is number, according to diagram 77, question 77. SR is what? 2 point? Sorry. Ada ke? SR. 1.0, sorry. 1.0, and then F is the highest, 4. So the difference will be 3, right? 3 more than? Only 3 numbers, either more than 2 or less than 0.4, right? 0.4. 2 magic number, more than 2 or less than 2.4. More than 2 become ionic bond. Less than 0.4 become non-polar. Non-polar or covalent bond. Non-polar or pure covalent. Yeah, remember these 2 numbers. The rest, if you understand the example 1, I don't need to go through B and C, right? Understand? I'll still give you the answer lah in my slides. Huh? So you check, the difference is 3. 3 refer to table. Right? More than 2 is ionic bond. Okay. So why this one is important? Because in later chapter, you need to balance the equation later. Balance the equation and then try to dilute the solution and so on. Right? Okay, so the rest I give you the answer. NCl is the same 3,3. So they are 0. So 0 is non-polar covalent. Right? N and O is 0, so also same. The covalent. Huh? Okay. All right. Okay. Is the bond formed between each pair items pure covalent? This one also same. This is your homework. Go. If you have question on this, you can come and ask me lah. Okay. Okay. Which one would you expect to be more polar? HCl, HBr. This question actually combine application of periodic table and also the colorful electromagnetic diagram in question 77. HCl, how many delta En? Huh? HCl. H is 2.1. Cl is 3. Different is 1 point something. So it's in the middle. HBr. H 2.1. Br is 2.8. So different is 0.7. Also in the middle, but the value is different. But it asks you about more polar, right? So if the number different is higher, then that become more polar. Okay. Yeah. Right. Polar bond. Okay. Does the presence of one or more polar bond in molecule always result in polar molecule? The answer is no. Okay. What we focus on is the net polar moment. So we need to add all the bonds together. Right? Polar molecule. Okay, CO2 is double bond. Double bond, if you check the table in question 77, the difference is 1, right? Check C and O. C is 2 point something, O is 3 point something, is 1. Right? However, CO2 has a linear geometry. By now you should be able to know why it's linear geometry. If you check the table previously in the question 63, the table, right? So you have a linear geometry. Dipole moment of one bond completely cancel the dipole moment of another one. So the molecule is called non-dipole. Means is looking at the net, the results in a molecular level. Right, got two sides. So this side will cancel another side. It's the same. This form covalent bond, but this have two sets. It will cancel each other. It will become a non-polar molecule. Okay. Now, previous example is only one element, two element, 1 plus 2, but this one is a molecule, right? Okay. So this one in CO2, you imagine is as the pole, it will be like pulling ropes. How we illustrate or how we present our answer that is a balanced dipole. For example, CO2, you know how to develop the Lewis model already. So in this case, if it's balanced, it is linear. How you write is a non-polar. You write a blue arrow point to the left, blue arrow point to the right. These two must the same shape, same length. It's like a vector, so they are balanced. Okay. CO2. This is water. Another one is water. Water, H2O. H2O, you know that the shape is bent, right? It's bent. So when it's bent, it will pull to the blue arrow. You see the how we write the thing. So this one, the red arrow is pointing the direction of the electron. H is sharing electron to the oxygen. Right? So O is negative. Right? The arrow must show the correct one. The arrow is pointing to the negative, the delta negative, because hydrogen is easier to give electron. So this side will become positive charge. Delta positive, delta negative. So arrow is pointing to the negative side. Yeah, pointing to the negative pole. Okay. Okay. So you are given this table in the tutorial, right? This one is in the tutorial. Okay, 86. So if the pole balance, it become non-polar, and there's a three polar bonds, then you have a polar. If it's unbalanced angle, it become polar. But if it's balanced like this, non-polar, right? This one you read. Okay, now it's important, because in later chapter, you need to identify whether it's polar or non-polar. So first step, how we determine the molecule is a polar. First step, determine whether the molecule contains polar bonds. You check the electronegativity. First, you check, first step, you determine whether they are polar bonds or not. You check polar bonds, keyword, check polar bonds. How you check polar bonds? Using the table, electronegativity table, the colorful chart. Okay, sometimes we will give you a table just by number, element and then number. Okay, so if there are no polar bonds, then molecule is non-polar. Number two, you sum up all the bonds together, you add together to form a net. You need to calculate how many dipole you have. Like how many dipole you need to check. Okay, now this one, how you check the bond? Again, use back the previous example by using VSEPR theory. This one you need to refer to the table, the shape of the electron geometry and also the molecular geometry. And that one. Okay, then you refer the bond as a rope pooling according to the diagram in tutorial 86. Referring to the center, pulling on the center atom. Okay, then you look whether it's symmetry or not. Okay. If it's symmetry, then non-polar. If not symmetry, then there's a polar. Okay. Right, so this one is how you determine whether polar or non-polar. So if it's cancel everything, non-polar. If there's asymmetric, means not symmetry. Asymmetry means not symmetry. Then become polar. Okay, so determine NH3 whether it's polar or not. We will repeat these two steps. First, you find whether you check the electronegativity, see whether it is polar bonds or not, got polar bonds. What type of polar bonds? Then you use the VSEPR theory to determine whether it is what geometry it have. So non-polar or non-polar. So first you draw the Levi structure. So we won't go through the step anymore, right? So there are 4 steps to establish the NH3 Levi structures. So this one, I assume you already know already. We'll skip all the steps. But if this one come out in your assessment assignment, please do the complete step. Huh? If you just straight away give me, you won't get the full mark for that particular question in your assignment. Yeah, so this example, I'll skip all the derivation steps for the Levi structures. Right. So you know that from this table, nitrogen and hydrogen, so you compare one set first. There are 3 sets to compare. And HN, 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 there are 3 sets to compare, but basically there are 3 elements. So you compare N, this N, nitrogen, N, and H. So it's about 0.9. 0.9 is between, is a polar. Right? If more than 0.4, less than 2. 0.4 and 2. So if 4 between is a polar. Okay. So you should be able to understand now why polar by referring to the magic number 0.2 or 0.4 or 2. Geometry, you check the table. Do you agree it's trigonopyramidal? Are you able to see? This one, how many electron groups? 3 or 4? 4, 4 electron groups. Bonding groups? 3. 1 lone pair. So what is that? It's the last 2, the last 2, So the electron geometry is tetrahedral, molecular geometry is trigonopyramidal. You're able to read the table already in tutorial question 6.3. Okay. Okay, so this one I show you already. Then you draw the dimension picture of NH3. Okay, so if it's a tripod, right? It's a tripod, pyramidal. It's like a tripod. So you pull like this. You look at the angle of pulling. It's 109. So the pull of the rod does not cancel. So if you draw the diagram, so this is a polarity chapter lah. If the question asks you polarity, you need to refer to all this. So we expect you to draw something like this. You need to draw the arrow, draw the presentation based on this one. Okay. In exam, I will give you the diagram. I won't give you the example. I need to remove this one, but I will give you this shape. You need to draw the shape, right? And then pointing to the negative electron. So this is polar. This is polar. So this one also, if you understand these steps, we just go through the example lah. Okay. So this one you check. Okay. This explain, if you understand polar, non-polar, this explain why 2 elements do not mix. So water and oil do not mix because water molecule, they are polar, oil, they are non-polar. How you can mix polar and polar? Only can mix. When there's polar and polar, because there is a different charges. Imagine different charges, the different positive can combine with the negative of another one. Then it can be mix. Non-polar means there is no charges. No charges, though cannot like magnet cannot stick together. So cannot stick, then cannot combine lah. So those solution that can remove grease one they are polar solution. The solution with polar molecule. Okay. The rest you read. This one is just illustration of south and north. This one you read. Okay. Yep. So with this, we conclude chapter 1. Next lecture, we go into chapter 2. Okay. All right. Your test will be in week 7. Let's take note. Any question?